Welcome to CoJo's Math. Today we're talking about circle graphs. Circle graphs are used typically for surveys or to organize data or something like that. In surveys, the one thing you have to remember that you have to have is you have to have a total number of people. And the total number of people have to equal the number of answers that you have for your survey. Remember, in a Venn diagram, we would have the total number of people surveyed, but we would have more answers than the total number of people surveyed. And that's why we had to use a Venn diagram. With the circle graph, your answers have to match the total number of people in the survey, or whatever you're counting, or whatever you're trying to graph. So remember that. The first thing you need to do, it says create a circle graph with the following information. If it gives you percentages, you have to add up all the percentages to see if they equal 100%. If they give you answers or responses from a survey, you have to add up the survey answers to see if they equal the number of people surveyed. If there's less or more, you can't use a circle graph, because 100% is represented by the total number of people surveyed. Okay, so there's 4 different categories for circle graphs. We've been talking about percents, fractions, and decimals. We can break up each one of these into a percent, where we're representing everything, the whole, with percentages. We can represent it with fractions to add up to 1. We can represent it with decimals that would add up to 1.00. And we can represent a circle graph or a circle with degrees. The reason why that's important, if you draw a circle graph, you need to know, if I tell you the percentages and I say draw a circle graph, in order to get the right angles, you have to use a protractor and you have to find the degrees. So you have to be able to convert percents, fractions, or decimals into degrees. We can do that by simple multiplication or by using the percent equation if we're going to use the percents. Okay? Or proportions. It's the same thing. So with degrees, the whole circle represents 360 degrees. So if I said 54% and I wanted to change that to degrees, I would say 54% times 360 divided by 100, because I have percent. Or I could set up a proportion or a percent equation and say 54% P over 100 equals X over 360 degrees. And then I can do my cross products and find out what that is, what the degrees are. Or I can simply do 0.54 times 360, because I'm dividing 54% by 100 to start, and what I get is that it's 194.4 degrees, and I have to put my degree sign so you know that I've done that. Okay. And I wanted to make this point because I want you to write this down. You must make sure that the survey responses add up to the total number of people surveyed. If you have more or less, then you have to use well, if you have less, you can't use anything. You can't show the information out on any kind of graph because you don't have enough answers. Somebody messed up. So if you have more than the responses than you're supposed to have of people surveyed, then you have to use a Venn diagram. So if you need to pause the video and write this down, do that. Okay, I'm going to move on. So how do we change a fraction, a percent, to a fraction? We write it over 100. 35 over 100, and we simply simplify. So that would be 7/20. Now you need to know how to do this at this point. If you don't, you need to come in and see me for some extra practice problems and for some extra help. How do you write 35% as a decimal? Well, you could go back to the fraction and say 7 divided by 20, but if I give you 35%, you just divide that by 100, or write that as 100, which becomes 0.35, and divide. Now how do you change it to degrees? We just talked about that. How do you do it? What do you do to the 35%? Degrees means it's out of how many? That's right, 360. So we could do a percent equation, or we could change this to a decimal and multiply times 360. When I do that, and yes, you'll be able to use a calculator, it's 126 degrees. Again, all of these 7/20ths, 0.35, 120 degrees, and 35% all represent the same value. They're all the same value, it's just different forms of numbers. All right, so how do you find actual numbers of people that represent percents in a circle graph? So I'll give you a circle graph, and I'll tell you all the percentages, and I'll tell you the number of people surveyed. And I'll say how many people like chocolate ice cream, or how many wins did they actually get. So the first thing you need to do is you need to add up to see the total number of people surveyed. You have to look for that somewhere in the circle graph, and the information given to you is told to you what the total number are. You take the total number of people and multiply by the percent change and change it to the decimal. Or you can use the percent equation. So all you're doing is finding the percent of a number. We've been doing that. Remember, 35% of 400, the of means to multiply. So if I have 48 games, and I have 80% were wins and 20% were losses, and I say how many of each did I have? Well, this is the total. That's like the survey, or the total number, 48 games. And we're going to multiply 48 times 0.8, because the decimal for that is, and I get 38.4 games. You can't win 38.4 games. So because this is below 5, it's 38 games. And then I can simply subtract and say 48 minus 38 is 20%, which would be 10 losses. Or I could multiply 48 times 0.2, which is going to give me 9.6, I believe. 9.6. Here we round up, and we have 10 games that were losses. So at this point in time, you're just using your information that you've already learned. Okay, now you try. 200 people, I want to know how many people like vanilla, chocolate, and other ice cream. Pause the video, do the problem, and then come back. Welcome back. Let's see how you did. So you could have done this using the percent equation or simply multiplying. For the vanilla, you should have had 130 people. For the chocolate, 70 people. And for the other, 10 people. Now, some of you might have seen the shortcut. Oh, it's out of 100, so I multiply it by 2. But it won't always be that simple. So you have to be careful. Because you could have said, okay, 65% of 100 is 65 people times 2 is 130. 35% of 200 is 35% of 100 is 35, and I've got 200 people, so it's times 2, which is 70. So it's another way of looking at it, shortcut. So now you're going to have something like this, and this is what we're going to be doing in class. You're going to get a circle graph, and you're going to have fractions, and you're going to have percents. I don't have a percent on this one. Sometimes you'll have percents, and degrees. And you have to find the missing parts. So if I have 9/20ths, and I want to change it to degrees, see the degrees? I'm going to use the percent equation. I think that's easier, or a proportion, really. So I'm going to say 9 to 20 equals what? X over 360. I get 20x equals, and I'll say 9 times 360, and I told you at this point in time you can just, so I get 3240, divide both sides by 20, and I get x equals 162 degrees. So this becomes 162 degrees. How would you find this one? If I know this is 162, this is 90, and this is 72, all the degrees add up to what? Right, 360. So I would add these three now, and I would subtract it from 360 to get my answer. If I wanted to get the fraction for 72 degrees here, I'd write 72 degrees over what? 360. And then I would simplify it, which is what I want you to do right now. I want you to find the fraction that goes right here, and I want you to simplify this fraction